Hello and welcome everyone. Today we continue our journey through the world of data visualization and data analyzing with the powerful tools every data science and AI expert should know about that is NumPy. This is Professor Abul Qasim from Department of Computer Science and Engineering, Sejong University. My TA and I, we arrange and prepare very nice slides for NumPy. Whether you are starting out or looking at the strengths, your foundation in the Python-based data processing, NumPy is an essential library. NumPy forms the backbone of many operations in the scientific computing, machine learning, large-scale data analyzing. In this section, we will start with the basic, what NumPy is, why it is important, and how you can use it efficiently to work with the array, perform mathematical computations, and accelerate your data pipeline. We'll explore hands-on example that will make these concepts, make clear, and by the end of this section, you will be confident in using NumPy for real-world tasks in AI and big data. So grab your laptop, open up your Python environment. For our case, we choose the Google Colab, and let's dive into world of NumPy together. Thank you.
Hello everyone, welcome to the NumPy tutorial. In this lesson, we will cover the basics of NumPy, the most important library for array manipulation in Python. Whether you are dealing with data science, machine learning, or even scientific computing, NumPy will be your go-to tool. Let's dive in. Before we start, I must say that these hands-on exercises are related to the notebook file for the course Artificial Intelligence and Big Data taught by Professor Abul Qasim Sadeghi Niareki, Associate Professor in Department of Computer Science and Engineering at Sejong University. Let's start our first title, brief overview of NumPy. NumPy, short for numerical Python, is a powerful library that makes working with arrays and matrices much easier. It's widely used because it's fast and integrates well with other Python libraries thanks to its underlying C-based operation. I mean, codes that are written in C or C++, which are very fast languages. So, we want to know how to import NumPy. Well, to start using NumPy, we need to import it to the Python language. We follow the common practices of importing NumPy with the alias np so that we can reference it easily throughout our code. I write in Python import NumPy as np, and I run it. Pay attention that we could alias it as any other word, but it's always best to use the alias that is most famous for each library. For NumPy, this alias is np. So because of that, we said import NumPy and alias it as np. Now, the first thing we want to learn, creating arrays from lists. Well, let's create our first NumPy array. You can convert a Python list into a NumPy array using np.array function. First, we'll create a simple one-dimensional array, which is also known as a vector. I say my list in Python is a list of 1, 2, 3. Then I say numpy.array, and I pass in the mylist variable. Well, as you can see here, we have an array of 1, 2, and 3. As you might already know, the difference between this array and a list is that in an array, as in languages like C or C++, the items are all put in a continuous block of code, which makes it very much memory efficient and also CPU efficient. So in lists, as opposed to arrays, the items aren't actually put together. They are in different parts of the memory, which has its own advantages, but it's not usually good when you're dealing with large amounts of memory. Similarly, we can create a two-dimensional array, also known as a matrix, by converting a list of lists into a NumPy array. Let's make a 3 by 3 matrix. Okay, if I say my matrix is, well, a list, and then the first item is another list, then the second item is also another list, and the third item is again a list. And here I can say use the array function and pass in my matrix. So as you can see here, we have a matrix, actually a 3 by 3 matrix. Okay, our next topic is how to use the built-in method to create arrays. NumPy also provides several built-in functions to generate arrays. These are especially useful when you need large arrays or arrays with specific values. Let's start with one of the most common methods, arrange, which generates evenly spaced values. I can say np.arrange like this. As you can see, here I have an array from 0 to 9, not including 10. You can also specify the step size in arrange. For example, let's create an array of even numbers between 0 and 10 by setting the step size to 2. np.arrange 0, 11, and 2, which is the step size. Okay, so we have 0, 2, 4, 6, 8, and 10, which are the even numbers going from 0 to 11, but not actually including 11, because our step size is 2, it goes 2 by 2. Now, let's explore how we can create arrays filled entirely with zeros. This is useful when you need to initialize arrays before performing operations. Here, we'll create an array of 3 zeros. I can say np.zeros 3. And as you can see, I have an array of 3 0 floating point values. Similarly, we can create multi-dimensional arrays filled with zeros by passing a tuple. Let's create a 5 by 5 array of zeros. I pass in a tuple, and here is our matrix. Next, we'll generate arrays filled with ones. This works exactly like np.zeros, but with ones function instead of zeros. Let's start with a one-dimensional array of 3 ones. np.ones instead of zeros and just a 3, which gives us a one-dimensional array. If we need a matrix of ones, we can pass a tuple specifying the dimensions. Let's create a 3 by 3 matrix of ones. Oops, sorry. First you call the function, then you pass in the tuple. Okay, let's go over our next topic. Using linspace to create arrays. Well, the linspace function generates evenly spaced values between two numbers. Unlike a range where you specify the step size, here you define how many values you want between the start and end points. Let's create 3 equally spaced points between 0 and 10. Linspace, which is our function. Then we have 0 to 10, and I want 3 points. So as you can see here, I have 3 evenly spaced points between 0 and 10. Pay attention that this time 10 is also included. If you need more precision, you can increase the number of points. For example, let's generate 50 evenly spaced points from 0 and 10. I can say np.linspace from 0 to 10, give me 50. Okay, next we want to talk about creating identity matrices. As you might know, in linear algebra, identity matrices are special matrices with ones on the diagonal and zeros everywhere else. NumPy makes it easy to create identity matrices using the I function. Let's generate a 4 by 4 identity matrix. So I can say np.I give me, yep. As you can see, I have a 4 by 4, identity matrix. Well, after talking a lot about arrays and matrices, let's dive into the world of randomness. First topic is random number generation. Okay. Well, random number generation is essential in data science, especially for tasks like initializing model parameters or creating randomized datasets. Let's start with rand, which generates random numbers between 0 and 1 from a uniform distribution. So I can say numpy.random package, the function rand, and pass in 2. Here, as you can see, these two numbers are two completely random numbers from a uniform distribution. Similarly, we can create a 5 by 5 matrix of random numbers between 0 and 1. This is useful when you want to quickly generate random data for testing. I can say np.random package.rand function 5 in 5. If we want random numbers from a normal or Gaussian distribution, we can use randn. This function returns numbers from a standard normal distribution, which includes both positive and negative values. Let's generate 2 random numbers from a normal distribution. np.random.randn, the n stands for normal, and as you can see, we have an array that includes 2 random numbers that also have negative values. And just like before, this time we can create a larger matrix of random numbers from a normal distribution. let's create a 5 by 5 matrix of values from a normal distribution. np.randompackage.randn 5 by 5. For random integers, we use the randint function. This function generates random integers between a specified range. Let's create an array of 10 random integers between 1 and 100. np.random.randint, okay, between 1 and 100, give me 10 random integers. As you can see, I have 10 random integers going from 1 to 100. Now that we know how to create arrays, let's explore some useful attributes and methods available in NumPy. First, let's create two arrays, one using a range and the other using random integers. Okay, so my first array is going to be np.arrange 25, for example. Well, this is a simple array of numbers from 0 to 24. Next, let's create a random array of integers between 0 and 50. Say random array, or just this, np.randompackage.randint from 0 to 50, give me 10 numbers. Okay, so at first, we want to talk about reshaping arrays. One of the powerful features of NumPy is the ability to reshape arrays. With the reshape function, you can change the shape of an array without altering the data. For example, let's reshape the array variable into a 5 by 5 matrix. So first we say shaping arrays. And we have array.reshape to a 5 to 5 thing. When using reshape, pay attention that if you multiply the two parameters passed into the reshape function, it must be equal to the number of elements in our original array. So right now, because we are saying 5 times 5, we must be sure that we have exactly 25 elements in our ARR variable. And another thing, notice that reshape does not affect the array object at all. In fact, it only returns another object created from the first object, but with different shape. So if I type in this, well, as you can see, we still have the same old array object. But if you do this, for example, five to 5, okay, so here, as you can see, I have saved the object created by the reshape method. This way of manipulating objects is common between both NumPy and Pandas library and is consistent with functional programming because of the immutability that it provides. Next, we want to talk about finding maximum and minimum values. Okay, let's move on to some useful methods for working with arrays. The max and min functions help you find the largest and smallest values in an array. With argmax and argmin functions, you can have the index of those values. Let's start with the maximum value in our rand array. Rand array.max. Now, as you can see, the maximum value in our random array was 45. Next, let's find the index of the maximum value using the argmax. So I say so it means that this 45 value was actually the first value in our array. And in the same way, we can find the minimum value in our rand array. And finally, let's find the index of the minimum value. Argmin. Okay, our next topic is checking the shape of an array. Again, one of the other useful methods that we have in arrays. Well, every array in NumPy, as you already might know, has a shape attribute, which tells us the dimensions of the array. Let's check the shape of our original array that we defined just right above. If I just call the shape attribute, notice that it's not a function, it's just an attribute. We get, okay, so this means that it's just a one-dimensional array with 25 elements. Now, let's reshape array into a matrix with 1 row and 25 columns and then see the new shape. If I say array, reshape it to 1 and 25, 1 row, 25 columns, and give me the shape of this new object. As you can see, it says you have 2-dimensional, 1 and 25. Similarly, we can reshape the array to 25 rows and 1 column, which would look like this. Array, reshape, 25 rows and 1 column. Give me the shape. Now the shape is 25 and 1, indicating that the array has 25 rows and 1 column. Reshaping arrays is an essential technique, especially when preparing data for machine learning models. Next topic, checking the data type of an array. Well, the last thing I want to say, NumPy arrays are homogeneous, meaning that all elements in the array must be of the same type. You can check the data type of the elements in an array using the dtype attribute. Let's check the data type of the array object. Dtype attribute tells us that, okay, so all the elements in this array are of type int64. Alright, that's a wrap. We've learned the basics of creating arrays, generating random numbers, reshaping arrays, and using important attributes and methods in NumPy. These skills form the foundation of working with data in Python. In next lesson, we'll explore more advanced topics like indexing, slicing, and broadcasting. See you there.
Okay, after finishing NumPy introduction section, now let's dive into NumPy indexing and selection. This part is very important in the NumPy. So TA and I, we are going to, introduce you some hands-on exercise. Please watch the video and pause the video while watching the video and practice more. This is the best way of learning. Thank you.
Hello everyone, welcome to the lecture on NumPy indexing and selection. In this lecture, we'll learn how to select elements or groups of elements from a NumPy array. Before we start, I must say that these hands-on exercises are related to the notebook file for the course Artificial Intelligence and Big Data taught by Professor Abulqasem Sadegh Niaraki, Associate Professor in the Department of Computer Science and Engineering at Sejong University. Let's jump right into our lesson by creating a sample array. Okay, First, let me write the title. It's going to be NumPy, indexing, and selection. What we have to do, as always, well, as usual, we'll start by importing NumPy as NP. This is common convention and we'll stick to it throughout our course. All right, next, we create a sample array going from 0 to 10. So here we are actually using the arrange function to create a sample array that goes from 0 to 10. Let's display it to confirm that it has been created. Going from 0 to 10. Okay. First thing we want to do with it, okay, now we'll learn how to select individual elements or slices from this array. It's similar to how we access elements in Python lists. We can say like this. Oops, sorry. So to actually get the value at a specific index, just use square brackets. For instance, if we want the value at index 8, we can use array square brackets 8 and it will return the value at that position. All right. Next thing we can do, we can say array, this time go from 1 to 5. So, as you might already guess, to get the values within a specific range, you can use slice notation. For example, here, array from 1 to 5 will give you the values starting from index 1 and up to, but not including, the index 5. Next, I can say this. You can actually get a range starting from index 0 just like this. This will return the first 5 elements from the array. Now, maybe we should talk about broadcasting. Alright, now let's explore an important feature of NumPy array, which is broadcasting. Broadcasting allows us to set values in an entire range of an array, unlike regular Python lists. For example, I can say array, first 5 elements are 100. So as you can see, here's an example of broadcasting. I can set multiple values at once. For instance, array going from 0 to 5, actually not including 5, so 0 to 4, will set the first 5 values in the array to 100, all of them. So if I do this, if we check out how the array looks after applying broadcasting, we'll see that the first 5 values are now all set to 100. Okay, now let's do this. So I'll actually reset the array back to its original state with values from 0 to 10, which will actually help us in understanding the upcoming concepts. Let's confirm that this actually has been set. Yep, it's correct right now. Okay. Next thing, important notes on slices. Alright, now let's take a closer look at the slices in NumPy. When you slice an array, you aren't actually creating a new array. Rather, you are creating a view of the original array. This means that any modifications to the slice will also affect the original array. So, what do I mean? For example, I have this guy which is set to. So here we create a slice from the array by selecting elements from index 0 to 5, actually not including 6. If I check it, yeah, that's correct. Now I'm gonna say change this, all of it, to 99. So yeah, let's change all the values in this slice to 99. All right, so let's first confirm that this is changed. All right, so I have actually changed the slice of my array. Now if I go back and check my original array, so as you can see, all the changes that I've made to my slice, they've also reflected in my original array as well. So my original array has also changed. If you want to prevent this and make sure changes in your slice do not affect the original array, you need to make an explicit copy of the array, like this. So here we are creating a copy of the array using the copy method. Now if you check it, yeah, if we display it, we see that it's identical to the original array, but now it's independent of it. Okay, next let's move on to 2D array or matrices. Indexing a 2D array or. Alright, the general format is writing the array and then passing the row and column numbers. For example, imagine my 2D array is, well, np.array. I'm gonna pass in this one, then give me 20, 25, and 30. Then also give me 35, 40, and 45. Let's check this. Okay, as you can see here, I'm actually creating a simple 3x3 matrix. Each inner list here, it actually represents a row in my matrix. So if I say so basically, to actually access a particular row, you just have to pass in the row index. For instance, array 2D1 here will return the second row, because remember, indexing starts from 0. And if we have 1, then we say 0. Well, if you actually want to access a specific element in the matrix, you can use double square brackets. Here, array 2D 1 and 0 gives us the element in the second row and in the first column. What if we say 1 and 0? So as you can see, a very more efficient way to index a specific element is actually by using a single pair of brackets and then separating the row and column with a comma. So this notation here has the same result as this one. Now let's talk about 2D array indexing. Alright, so let's move on to slicing 2D arrays. Just like with 1D arrays, we can also slice 2D arrays easily. We say our array, this one for row and this one for column. Here is an example of slicing a 2 by 2 submatrix from the top right corner of our initial array. We use the slice notations for both row and columns. So array 2D going from 0 to 1 and then going from 1 to the end selects the first two rows and columns starting from index 1. You can also say so basically to grab the entire bottom row, simply pass in the index for the last row. In this case, this is actually array 2D and the number 2. What if we say this and then we do this? So, yep. Another way to grab the entire bottom row is by using a column slice. So here, this one is actually equal to this one. Next thing we want to talk about, fancy indexing. Alright, now let's talk about fancy indexing. Well, this is actually an ability that allows us to select entire rows or columns in a specific order. For example, what if I reassign, well, not actually reassign, let's create a new one, np.zeros, and pass in a tuple. Alright, so here we'll set up a 10 by 10 matrix of zeros using their zeros function. And then I say this one. So we'll actually grab the length of the array using the shape attribute. And, second element of the shape attribute gives us the number of columns. I can say in this loop, well, do this assignment. So, well, in this loop, we populate the array such that each row contains the index number I. For instance, the first row will be all zeros, the second row will be all 1, and so on. So if I actually display it, you can see the results right here. And now we get to fancy index it. I can say 2, 4, 6, and 8. I'm passing in a list. So as you can see, using fancy indexing, we can select multiple rows all at once. Here, this array and this list will return rows containing 2, 4, 6, and 8. So, well, this is the third one, this is the fourth row, this is the fifth row, and so on. To tell you something more, what if we said 6, 4, 2, and then go up to 7? So what I want you to notice here is that fancy indexing allows us to select rows in any order. So for example, going from 6 to 4 to 2 and then to 7 will also work just fine.
Next thing we want to talk about selection with comparison operators. So let's explore how we can use comparison operators to select specific elements from an array. First, let's create an array with values ranging from 1 to 10. I have an array that goes from 1 to 10. We'll use this for comparison operations. Now, first, let's display the array to check that it has the correct values. Okay, we can apply comparison operators directly to the array. For instance, I can say array being greater than 4. So array greater than 4 will actually return a Boolean array here, where each element is true if the corresponding element in the original array is actually greater than 4 and false otherwise. Because the first 3 elements here are less than 4, then as you can see, the first 3 elements in this Boolean array have actually returned false. So let's say the Boolean array is this array. So let's actually store the Boolean array in a variable called bool array. And if I just print it, we see it's the same thing. So what I want to tell you is that we can use this Boolean array to filter the original array. So I mean, I can say, put the original array here and then pass in the Boolean array in a square bracket. Then what you get, this array, square brackets, and passing in that Boolean array that we made just right above, will actually return only the elements where the Boolean array is true. So starting from the 5th element and moving forward. So as you can see right now, we just use this Boolean array to filter our original array. A simpler way to filter values is to apply the comparison directly. What I mean by this, I mean I can more easily say I want the array square brackets where it's bigger than 2. So yeah, this one will return all the values in my original array that are greater than 2. As you can see, this is simpler than combining a Boolean array with the original one, as we just mentioned above. So you have 2 ways, but this one is just simpler. We can also use a variable for the comparison. Imagine I have this variable and I say, okay, the original array, anything that's bigger than x. Alright, that wraps up our lecture on NumPy indexing and selection 2. Well, we've covered how to access and manipulate arrays, work with the slices, and perform selections based on conditions. The best way to make sure that you've learned everything that we've taught so far is to create an interactive notebook yourself and try doing every example that we've taught here by yourself. So remember, practice always makes the best learning.
Okay, after finishing NumPy indexing and selection, we are going to dive into NumPy operation, because you need to do many mathematical operation using the NumPy. So this part is very important.
Welcome back, everyone. In this article, we are going to explore some fundamental NumPy operations, starting with arithmetic operations on arrays and ending with universal array functions. These operations are key when you are performing computations across arrays. Before we start, I must say that these hands-on exercises are related to the notebook file for the course Artificial Intelligence and Big Data taught by Professor Abolqasem Sadegh Niaraki, Associate Professor in the Department of Computer Science and Engineering at Sejong University. So let's jump right into it. I want to talk about arithmetic operations. First, let's see how we can perform basic arithmetic operations between arrays or between an array and a scalar. For this, we'll start by importing the NumPy and creating a simple array using the arrange function. Import NumPy as np as usual, and just give me a sample array, 1r. Okay, so here we created an array containing values going from 0 to 9. Now, let's try some basic arithmetic operations. First of all, let's try adding the array to itself. So notice that this addition is happening on each element of the array. Now, let's try multiplication, where we multiply the array by itself element-wise. Array times array. So, similarly, the elements in the array are squared when multiplying the array with itself. Next, let's subtract the array from itself to see what happens. If I say this, well, as you can see, this results in an array of zeros because each element is actually subtracted by its own value. Next, we want to talk about division and special cases. Okay, so now let's see what happens when we divide the array by itself. But be aware, there's an interesting behavior here when you divide things by 0. So if I say divide the array by itself, well, you'll actually notice that NumPy doesn't throw an error when we divide by 0, but it returns none for the first element, which stands for not a number, because 0 divided by 0 is undefined. However, for all other divisions, we see that it results in 1, since a number divided by itself is 1. So let's just see another scenario here, where we divide a scalar by an array. So this time we get a warning and infinity for the first element. This happens because 1 divided by 0 is mathematically infinite, and NumPy captures this gracefully. What about exponentiation? Alright, so lastly, let's look at how we can raise each element of the array to a power. For example, cubing each element in the array will look like this. Double asterisk. So yeah, as you can see, each element is raised to the power of 3. Then we want to talk about universal array functions. Okay, so now let's explore some of the NumPy's universal array functions. These functions allow you to apply common mathematical operations to each element of an array. So we can say, we can start by taking the square root of each value in our array. So this actually returns the square root of each element in the array. And notice that if you have negative numbers in your array, this function would return complex values. Next, let's compute the exponential of each element. If I say np exponential of my array, what does it say? So, as expected, this computes e raised to the power of each element in my array. Alright, let's now see how we can find the maximum value in the array using the universal function np.max. Even though we can actually just call it on the array itself, it's not bad to know this one exists too. So the maximum value in our array is 9. This method and this one, they all give you the same result. Now let's move on to some trigonometric functions. Here's how you can apply the sine function to every element of the array. You say np.sine. Yeah, the sine function is applied element-wise, just like the other universal functions. Finally, let's take the logarithm of each element in the array using np.log. Remember, the logarithm of 0 is undefined, so this will raise a warning. If I say np.log, yeah, as you can see, divide by 0 encountered in log, and we actually have this minus infinite in here too. Okay, this wraps up this section. You have just learned how to perform various arithmetic operations and use universal functions in NumPy. With these tools, you can now start performing complex numerical calculations on your arrays. See you in the next lecture where we continue diving into more advanced NumPy features.
And finally, let's go the last section of the NumPy. In this section, we will try to do some exercise in the area of NumPy. This is the last section. Please practice more, and I would like to suggest watch video this section more and review whole video many times. Thank you very much.
Hey everyone, welcome to the NumPy exercises section. Now that you've covered the basics of NumPy, it's time to put your skills to the test. We'll begin with some simpler tasks and then work our way up to more advanced operations. Don't worry, because I will guide you through each step. So, as always, the first step is to import the NumPy library. Let's import it using the common alias np. Then let's start by creating an array of 10 zeros. This is a very straightforward task in NumPy because it can be done using the np.zeros function. Alright, next, let's create an array of 10 ones using the np.ones function. This works just like the zeros function, but fills the arrays with ones. np.ones, give me 10 ones. Now, how about creating an array of 10 fives? One way to achieve this is by creating an array of ones and then multiplying it by 5. It's a little tricky, right? Say, first give me an array of ones, then multiply it by 5. Next, let's create an array that contains the integers from 10 to 50. For this, we can use the NumPy's arrange function. Now, let's create an array of all the even integers from 10 to 50. We'll again use the arrange, but this time we'll set the step size to 2. So I have to tell you np.arrange 10, 51, and the step size is also 2. This gives us the even functions. Alright. Next, let's create a 3x3 matrix with values ranging from 0 to 8. We can use the arrange function to get the values and then reshape the array into a 3x3 matrix. First, give me the base function, definitely 9 values because it's 3x3, and then reshape it into a matrix. Okay. Identity. An identity matrix is a square matrix where the diagonal elements are 1 and the rest are 0. Let's create a 3x3 identity matrix using the np.I function. Now, let's generate a random number between 0 and 1 using np.random.rand. This function returns random values sampled from a uniform distribution over the interval 0 to 1, but not actually including 1. This is what this question wants. Okay. Let me just move it. Yeah. Next, we want to generate an array of 25 random numbers, this time sampled from a standard normal distribution, which has a mean of 0 and a standard deviation of 1. For that, we use np.random.randn. For this task, we'll create a matrix where the values go from 0.01 to 1 in steps of 0.01. We'll use the arrange function and then divide the values by 100. I have to put it in here. So at first, give me the base function again with the range 1 to 100, and then reshape it to a matrix, and then divide it all by 100. Yeah, it's the same output. Alright, now let's create an array of 20 linearly spaced points between 0 and 1. For this, we use the linspace function. np linear space 0, 1, 20. Yep. Great job so far. Now let's move on to NumPy indexing and selection. In this section, you'll work with matrices and practice selecting and slicing data from arrays. Let's use the matrix defined below and solve the task step by step. So I just run this because we are going to use this matrix. Okay, so let's start by replicating the output shown. We need to select certain rows and columns from our matrix. If I want to replicate this output, I have to say start from row 2, and in columns, start from column 1 and go to the end. So this way, it actually slices the array to our output. For the next task, we'll select a single element from the matrix. Let's get the element at the 4th row and 5th column. Here. So we call our matrix 4th row and 5th column, and there it is, 20. Next, we'll select a column slice from the matrix. Let's grab the second column of the 3 first rows. If I want to produce this output, I say choose the three rows and this column. So yeah, it's the same thing. In this task, we want to grab the entire last row of the matrix. This is how it's done. Say the matrix, last row, and all of it. For the final selection task, let's grab the last 2 rows of our matrix. The last 2 rows, all the columns. Okay, now let's wrap up the exercise with a few more operations. First, let's calculate the sum of all the values in the matrix using the sum method. Sum. Yep. And next, let's find the standard deviation of the values in the matrix using std function. And finally, we'll calculate the sum of all the columns in the matrix. For this, we pass the axis equals 0 argument to the sum function. Fantastic work! You've successfully completed the NumPy exercises covering everything from basic array creation to indexing, selection, and advanced operations. Make sure you practice these concepts as they form the foundation for more complex data science workflows. See you in the next session.